In 7.5, we are going to be going through conditional probabilities. So to start, let's set up two events in our experiment where we draw one card from a deck of cards. So we are going to let A be the event that a heart is drawn. And it has these 13 cards in it, the 13 hearts from our deck. And then event B is going to be the event that a face card is drawn. And that is our 12 face cards from the deck of cards. And now what I want to know is, what is the probability of drawing a face card given that the card is a heart? So imagine this is like a scenario where you have a friend and they drew a card from the deck of cards and they gave you a hint and told you that the card that they drew is a heart. And now from there, you want to then figure out, now what is your probability that that card is also a face card? In this case, we know that it's a heart. And what is the probability of the face card? This then is what it's doing, is restricting the sample space to that event where it is a heart. So we are essentially now looking only at our event A, where a heart is drawn, and wanting to figure out from there, what is the probability that it's a face card? Well, we have three face cards in our set of the hearts. So our probability that it is a face card, given that it is a heart, is going to be 3, but it's not out of our 52 cards because we restricted it to this event where a heart is drawn. And we have 13 different hearts, so this probability is 3 out of 13. And this is what we consider conditional probability. We are finding the probability of something on the condition that something else has already happened. So our definition and formula for this, our probability of B, given that A has already happened, and this straight line is our shorthand for given, this is equal to our probability of A and B happening, so probability of both of those two events happening at the same time, divided by our probability of A. But a lot of the times we're not evaluating the probabilities of these, and we like to be able to work with these with just the number of elements in these sets. So another way that we can write this is to think of this as being the number of elements that A and B share, divided by the number of elements in A. And this is because we are essentially restricting our sample space to A. So we no longer have our sample space, number of elements in our sample space in our denominator, but we now have the number of elements in A, what we have restricted, shrunk down the sample space to be.